Hello everyone. We seem to find Practical 6 difficult this week, and that's fair enough, it's a tricky problem. So I thought I'd put this video up to show you how to solve this problem. Now, I'm not going to have this sheet up at all times, so it might be useful for you to have it up in a different window or something like that while you watch the video. But we'll have a quick look at it to get started. So we're told that we want to emulate this loop here. We're given some high level code. So we want to set a to be equal to 0. And perform the multiplication of m by q by shifting and adding. So this is the same algorithm that we saw when we did video 7.1, binary multiplication. So if you manage to get the answer and you just don't quite 100% understand what your code is doing, that video might be helpful to you. I'm not going to go over it in too much detail here. Suffice it to say, this loop is equivalent to multiplication. So we're told that we've got two 16-bit numbers. We want to load them into A0, or load them from A0 and A1, multiply them together and put the product in V0. We're not allowed to use any multiplication or division instructions. So let's see how we would do that. So I've got the values up here. Now, one thing that was a very common error in this exercise was not setting V0 to be equal to 0. Now, we'll find out in next week's why this is a very important step. For the moment, I'll just say subroutines can put values in V0, so it's very important that you clear it out just in case, because the test suite does include a lot of subroutines, so it can change the value of that before your code even executes. Next, I want to load the half words from T0, or into T0 from A0, and this is going to be my Q, T1, and this is going to be A1. And this will be my m. So I've got all of my immediate values. Now I just need to get started with the loop. So I'm going to loop, and so this is going to be my Mult Loop. And the first thing that the question said was that you want to, if the least significant bit of q is 1, then you want to do a equals a plus m. So we need to extract the least significant bit and see if it's 0. So let's T0 with T0 and the value of 1. So get least significant bit. Now remember, and is an extracts values, so anding it with 1 will tell me if there's a 1 or a 0 in the least significant bit column. So then what I want to do is branch if equal to 0, because if this is 0 I want to skip my arithmetic. So if T0, oh no, we don't want to put that in T0, actually that's a bad idea because then we'll overwrite our value immediately, so let's put T0. Then I'll go to shift, and let's put a little shift label down here. And then if I fail that branch where the least significant bit is not equal to 0, I should do my add. So we're doing V0 plus V0 plus, oh geez, oh, can I type, T1. And this is my A equals a plus m. So far so good. Now what we want to do is shift the values and loop back to the start. So I want to shift left logical the value of T1. Now remember in the multiplication by shifting video, that's what allows me to do multiplication by adding. We shift so that the place value is moved up every time we check another bit, and that's what we're doing here. So I want to shift right as well the value in T0. And this will change what the least significant bit is so that we can easily take out the least significant bit by leaving this code the same. And then what we want to do is say branch if not 0 the value that's in T0, because if we've shifted right we could wind up at 0 for T0. So if it's not 0 we want to jump to the Mult Loop. Otherwise we'll just fall down the bottom here and that's us done. Now we don't want to jump back up here because we'd overwrite a every time we did, and we don't want to load the new value, the same values out over and over again. We just want to start from this multiplication loop here. So one thing we want to do as well is make sure this is unsigned. So if there's any overflow errors from sign extension and multiplication, we don't want to have to worry about that. So let's assemble and run. And there we go, we've got 5 out of 5. Well done me. So now that I have this, I can use this for the next part. If we have a look at the next part, it says we want to do the vector dot product, and that really just means we're multiplying equivalent parts of two arrays together and summing their output. So if I have two arrays, I just take out the first element, multiply them together from each array, add them to the total, go to the next element, multiply them both together, add to the total. So we're also told we're not allowed to use any multiplication or division instructions, and we're told that length is given in A2. So what we would want to do immediately is copy this, because this is multiplication. So we want to be able to multiply, and we're not allowed to use mult, so let's use this instead. So then what I also want to do is right off the bat load into v0 the value of 0, and then I'm going to start an initialization loop. So init loop, and I'm going to load the half words from a0, or at least the pointer of a0. I put them in the same values so that I don't have, or in the same register, so that I don't have to change my mult loop. Now, as soon as I've loaded the values, I want to then multiply them together. That's what this is going to do, so I don't really need to worry about anything in here. But once that's done, I do want to do the incrementing so that I can go to the next value in the array. Now the array is half words, as we can see here, so we want to skip past by adding 2 onto the pointers. And I'm going to add onto A1 value of 2 as well. Now one thing that we do have here is we were told that we had the length, this immediate value of 5, so I should use that so I know I'm at the end of the array. Now I'm not going to make a new counter that adds up to 5, I'm just going to subtract from 5 so that when we're equal to 0 I know that we're done. So bottom here I'm going to add immediately onto A2 minus 1. You could equivalently do sub 1, it's fine either way. I'm just doing it this way because this is the way I prefer, and I'm going to put an end label there so I can skip all of this if we're done. Now how will I know if I'm done? Well, I'll know we're done if A2 has gone to 0. So at the start here I'm going to do BQ0 A2 then end. So overall what I'm saying is make sure that A is equal to 0, or V0 is equal to 0 in this case. If my counter has reached 0, we're at the end, so we should just go to the end. Otherwise, load the values from the pointers, do the whole multiplication business, and if this fails, once we've gone to the end of the multiplication, we'll drop down to update the pointers by 2, which is the size of a half word, so we're just going to the next element of the array, decrement the counter, and we'll need a jump, won't we? We'll need to jump back to the init loop so that we can keep going back to the start and repeat the loop. So let's make sure the tests are included, assemble this and run it and hope for the best. No errors, that's always a good sign, and let's run that. And there we go, 5 out of 5. So I hope you found this useful. I know this was a tricky exercise. I think once you get 6A it's really quite easy. This is the tricky bit where you have to do some thinking. Lab 6B, mainly you're just setting up a loop around a loop, which we've done before, so this isn't too much to worry about. But yeah, if you have any questions about this, please do let me know. Thanks.